So at the end of the last video I did example 4 and I had a typo in it, and the software that I was using to make the video won't let me pause and go back and fix the typo, and I didn't want to redo the whole video, but I said what it was, but I wanted to make sure I included here. The last term should be a -3. I had a -2. It was a typo looking at the numbers. Probably looked at that 2 or something. But it should have been -1 times 3 would be -3. Okay. And let's move on to the next example then. So the last example of this section, solve by factor by grouping and state the multiplicity of each root. So I don't think we get any complex answers here, but we're going to do factor by grouping, and we have the fundamental theorem that we should have 3 zeros, but we may have repeats, or we could have complex, but turns out I think we're going to get a repeat. So we're going to do factor by grouping because we have 4 terms. So we group them up. We got x to the third minus 2x squared. I'm going to group that up. And then I'm going to split it as a plus minus 4x plus 8 and group it up that way. And then we remove the greatest common factor, factor out the greatest common factor from each of the pairs. So out of x to the third minus 2x squared, we can factor out x squared and be left with x minus 2. And if we factor -4 out of the second pair here, we're also left with an x minus 2. And since that matches, we can factor out the x minus 2 and be left with x squared minus 4. So we can factor this into x squared minus 4 times x minus 2, and if we want, we can go one more step and factor x squared minus 4 into x minus 2 times x plus 2. So there's the complete factorization. This time we have a repeated root. We have 2, 2, and -2 if we were to list the 3 roots. We have a repeat. We really only have 2 real ones. We have 2 and -2, but if we count them the right way and count the repeats, we have 2, -2, and 2. So x equals 2 is a root of multiplicity 2. X equals -2 is a root of multiplicity 1. Just to remind you, in the section where we talked about graphing the polynomials, when the multiplicity is odd, like at x equals -2, this graph would cross the x-axis. Where the multiplicity is even, at x equals 2, there would either be a local max or local min on the axis.